Welcome to Cambridge International AS Level Chemistry. In this course, now I want to discuss about the chapter Introduction to Organic Chemistry. We want to discuss the structural formula. There are three types of structural formula. Skeletal structural. Strange structural, we show actual number of atoms. This is the chain structural formula. Displayed formula showing all the bonds. If you show the displayed of this one, 4 carbons, this is displayed, showing all the bonds. We have shown here carbon-carbon single bond and carbon-hydrogen single bond. Skeletal formula, actually we show the bonds in the functional group. If we see the skeletal formula here, 1, 2, 3, 4 carbons, 1, 2, 3 and 4 corners. So this is the skeletal formula. We want to see the more example of skeletal formula. Another one, say this is organic molecule habit-wise group. The skeletal will be, we have here 1, 2, 3, 4 carbons. So 1, 2, 3, 4. So for the 4 carbons, we're writing the main one first. This is the main one, but at position 1 and 2 there is a branch. Branch is the OH. This is the skeletal formula. Another example we want to show, COOH. The skeletal formula, it will be like that: 1, 2, 3, 4. The last carbon you have the functional group, so you have to show the functional group. And CH not carbon, not hydrogen. Now I want to discuss about the 3D structure of organic molecule. 3D structure. For the 3D structure, 3 different rows here. The first one, the normal line. Then it will be the wedge shape, broken line and normal line. These are the, this is normal line. If you see here OH, we can put here CH3 or anything, H, chlorine. This is 3D structure, and pure will be this side. This is wedge shape, broken line. That is, this is not in this side. The chlorine is present in the opposite side of this one. So this 3 rule you have to maintain. Any type of formula we can write in 3D structure. Now I want to discuss about the functional group of organic molecule. Functional group. Functional group is the main one. We can understand or we can define any organic molecule seeing its functional group. So functional group, different functional group, carboxylic acid functional group is COOH. These are the most common functional group for the AS level. The carboxylic acid has the higher priority. The priority increases. If you see the structural formula of this functional group, it will be easy for you to understand. This is the structural formula of. Then I want to discuss naming of organic molecule. For the naming, we have to follow some formula. Number of member in the main chain and the functional group and branch, position of branch. The first one, this is a alkane. The alkane butane. Butane is the normal butane. But we can add different functional group. So if you add here functional group, this will be butene. Here the functional group is in, so it will be on H. This is H. The functional group is here alcohol. So this is alcohol. The main name will be in the main chain total carbon 4. So butane and 2 position there is a functional group 2. Functional group is OH. That is alcohol. Butane 2 hol. This is the naming. We can also name this one. If we give the functional group here, the naming will be 1 hol. If we have more than one functional group, like we are giving here OH, EH, And here we want to show here you have two functional groups. The first one carboxylic acid, another one is OH. In the functional group list, you know already carboxylic acid has the higher priority, so the naming will be according to the priority order. So this is number 1 carbon, 2, 3, and this is 4 number carbon. So in the number 1 carbon you have carboxylic acid functional group, so it will be butanoic acid, but there is a branch at position 3. This will be the branch. So the naming will be 3 hydroxy 3 hydroxy butanoic acid. This is the naming. Now I am going to discuss about different terminology like homocyclic fission, heterolytic fission, nucleophile, electrophile, free radical. Let's see. Here there is a covalent bond. The covalent bond can be broken in two ways. First one, we want to break in equally, that is, here is a one pair of shared electrons, it can break like this way, radical. So this is called homolytic, and these two are called free radicals, because electrons are shared equally. One is taken by carbon, another is taken by chlorine. We can make it different symbol, it will be easy for you to understand. And then we want to break this bond unevenly, that is heterolytic fission. The heterolytic fission, it will be just like that. The both electrons are taken by the chlorine. So here positive and negative ions are made, unequally broken the bond. So this one is positive, this one is negative. Negative will be the nucleophile, and this one is electrophile. Electron will move towards this one, so this is electrophile, and this will move towards nucleus, so this is called nucleophile. So here we have discussed already 5 terms: homolytic fission, heterolytic fission, free radicals, electrophile, nucleophile. Isomerism. Isomerisms are two types: structural and stereo. The structural isomerism first. It has two types: structural and isomerism. Structural isomerism and stereo isomerism. Structural isomerisms are two-dimensional isomerism, and the stereo isomerism are 3D isomerism. Structural formula here: the same spatial arrangement. Different spatial arrangement. Now detail structural isomerism. Structural isomerism are 3 types. First one, chain position isomerism. If I tell regarding chain isomerism, same molecular formula but the structure different due to the chain. Let's see. C4H10. This is butane. This is the molecular formula. We can draw the two structural formula of this one. The first one, this is butane, normal butane. But we can, this is also structural formula of C4H10, but the structure different. The first one is normal butane and this is propane, 2-methyl propane. This is normal butane and this one 2-methyl propane. This is normal butane, 2-methyl propane. Now I want to discuss functional group isomerism. The same molecular formula but functional group different. C2H6O. This is a molecular formula. This is molecular formula. We can draw two different structure of C2H6O. It's just like that. It's ethanol. This is ethanol. Ethanol, the functional group is OH. We can draw another one. 3. This is methoxymethane, alkoxy compound. So different functional group different. These two have the same molecular formula. So ethanol and alkoxyalkane, these two are called functional group isomers. Now position isomers. Position isomers, same functional group, the position different. Propan-1-ol. Propan-1-ol position at position 1. This is propan-2-ol. The first one is propan-1-ol, the second one is propan-2-ol. These two have different structure due to the position of the functional group. Both are alcohol, that position different. Number 1 carbon position and number 2 carbon. Now I want to discuss about stereoisomerism. Stereoisomerism are two types, geometric or cis-trans and optical isomerism. Stereoisomerisms are made due to the spatial arrangement. Already I told the same structural, same molecular, but the arrangement different. Let's see. Geometric isomerism. Geometric isomerism is also called cis-trans isomerism. I want to give the example here. These two are geometric isomer. The same structural formula, same molecular formula as well, but the difference is arrangement different. Here we have restricted of rotation. Any molecule, any structure we can find, this is called restricted of rotation, and these are free of rotation. The two carbons here are in restricted of rotation. Again I'm taking the two carbons are in restricted of rotation, but two bonds are here free of rotation. These bonds restricted rotation, 1 sigma, 1 pi. Due to the pi bond, it cannot rotate. Here also restricted rotation. These two bonds are free of rotation, can rotate freely. It's just like that. If you see here, you can rotate, but here not. So restricted rotation and the free of rotation. The free of rotation groups are different. These are the thing. So I'm giving here for the stereoisomerism. Group different rotation. Restricted rotation, free of rotation, and group different and free of rotation. If you see here, these groups are different in the same carbon, different group. But here the arrangement, how it is different, the two chlorine are in the same side, but here the second diagram, the two chlorines are in different side, opposite side. So this is called cis-trans. Cis-1,2 dichloroethene. Cis. For the restricted of rotation, not only the double bond is responsible, also in the single bond, but the closed ring, that is also responsible for restricted of rotation. I want to give another example for restricted of rotation. This structure has both free of rotation and restricted of rotation. Here the closed ring, so these two carbons, though it has single bond, but this is restricted of rotation. This is similar way, restricted of rotation, but these two bonds are free of rotation, has different group. Free of rotation different group, free of rotation same group. Two both are here hydrogen. So for this side there will be no geometric isomerism, but here for this one it can be geometric isomerism. Now, optical isomerism. Optical isomerism are created due to the chiral center. I want to see the chiral center. This carbon has 4 different groups. The chiral center. Chiral center. This carbon has 4 different groups. We can write here. This will be the chiral. So it is chlorine, it is OH, ACE and CH3. So this carbon is chiral. Again, I'm telling the carbon has 4 bonds, but here the 4 bonds are different. So this carbon is called chiral carbon. So due to the chiral carbon, it has optical isomerism. Same structural formula, same molecular formula, but the arrangement different due to the chiral center. If you want to see, it can create the mirror image. This is one of the 3D diagram. Mirror image will be just like that. The left side will be the right side. Close. These two are optical isomers because these two are non-superimposable. If you want to show here, these 2 hands of me are not superimposed, not superimposed, just like that. If we cut this one and place on it, it can't be superimposed. These 2 are non-superimposable and they can create mirror image. So here you have to understand regarding polarized light. When polarized light is passed through this compound, the light will be rotated in its plane, clockwise or anti-clockwise. So these 2 are called enantiomers. But it can create also racemic mixture, but that is not our interest. We want to see the optical isomerism. You can find anywhere the optical isomerism. I want to give the more example how to find out the chiral center. Many candidates fall in problem when skeletal formula are given. I want to discuss how to find out the chiral center in a skeletal formula. Let's see. We have to find out from here how many chiral are there. First, if you want to see here, if you write the discrete formula of this one, it will be easy to you. But here we know 1 carbon, each corner has 1 carbon, and it has also 1 hydrogen. It has also 2 hydrogens. It has no hydrogen. It has also another hydrogen. It has also another hydrogen. Here it is 2 hydrogens. You need not. So these are not chiral. But this is chiral. I'm making the circle because one is the ring, and that side also another ring, but not similar. 2 groups different. So this is chiral. This is also chiral. Similarly, this is also chiral. This is 4 different. We can total 4 chiral centers. Do you have any confusion? You can write to the comment. In the chapter Introduction to Organic Chemistry, if you have any problem, you can communicate us at Catalyst Education without any hesitation. Catalyst Education has both face-to-face and online education platform. Thank you very much.